Hello and welcome to Uncle Matt's Online Academy. In today's lesson, we want to continue with our discussion on density. In the previous lesson, we discussed or we introduced the concept of density. We defined density, gave the formula for density and the units of density, and also solved few examples. In today's lesson, we want to look at how we can determine the density of a solid. How we can determine the density of a solid. So how do we do it? We know that solids, we have two kinds of solids. We have a regular solid and we have irregular solid. We have a regular solid and irregular solid, regular solid and irregular solid. The way we determine the density of regular solid is different from the way we determine the density of irregular solid. And what is a regular solid and irregular solid? A regular solid is a solid that has a regular shape. A regular shape is a definite shape that you can easily get the dimension, like square, like rectangle, like a rhombus, like cube. We can get the dimension of this kind of shape. But when somebody gives you a chunk of wood or a stone that is not carved, it does not have any particular shape, any definite shape. So these ones that don't have any particular shape or definite shape, they are called irregular solids. But the ones that have shape that are known, shape that you can easily recognize, like rectangle, like square, like cube, they are called regular solids. For regular solids, if we want to get the density of a regular solid, if we want to get the density of a regular solid, what we do is that we get the instrument called weighing balance. A weighing balance is used to get the mass of an object. Now, because every solid is a rigid object, meaning that you can hold it, we can put the regular solid or the solid on the weighing balance and get the mass of it directly. When we get the mass, we keep it. Then for the volume of the regular solid, we use a meter rule and get the dimensions of it, maybe the length, the weight, and the height, whatever that is needed for us to get the volume of the solid. If it is a rectangular block, for example, to get the volume of a rectangle, it is we times the length, the weight, and the height. So when we multiply the length, the width, and height, we get the volume of a rectangular block. And so we divide the mass we've gotten by measuring it on a weighing balance by the volume we got by multiplying the dimensions. And that will give us the density of the object, of the regular object. If it is a cube, the volume of a cube is L cube, L raised to power 3. So if you have one of its lengths, we multiply it by 3 into 3 times, and that will give us the volume of the cube. So when we get the mass, we divide it by the volume we've calculated, and that will give us the density of the cubic regular solid. So for other shape, we find a way to calculate the volume using the dimension, and when we calculate it, we divide the mass which we got by weighing it by the volume we got by calculating the volume, the dimension. So that will give us, that is how we determine the density of a regular solid. So the density of a regular solid is equal to the mass gotten by weighing it directly on a weighing balance all over the volume which we get by multiplying or calculating the dimension of the regular solid. So this is how to get the density of a regular solid. For example, in an exam, they may give us a question that looks like this. Example 1. We can have that a cube shaped block has a length of 2 cm if it weighs 20 kilogram, calculate its density. So how do we calculate this? Here we know the mass is equal to 20 kilogram, and we know that it has a length is equal to 2 cm, and it is a cubic object. The volume of a cube V is equal to L raised to power 3, so which is equal to 2 raised to power 3. This gives us 8 cm. Now our mass is in kg. The unit of density is kilogram per meter cube or gram per cm cube. So here we have kg, so we must have meters to balance the units. So we are going to convert this cm cube to meter cube. To convert cm to meter, we divide by 1000. So this will give us now 8/1000, and that gives us 0.008 meter cube, 0.00 meter cube. And with this, we now calculate the density. D is equal to mass over volume, which is equal to now 20/0.008, and this will give us 2500 kilogram per meter cube. So this is the answer. Now we look at the density of irregular objects. Density of an irregular object. How do we get the density of an irregular object? For irregular objects, to get the density of an irregular object or irregular solid, what we do is that we still use our weighing balance to get the mass of the irregular objects. So we get the mass using direct determination on weighing balance. So we get the mass by weighing it on a weighing balance to get the mass of the irregular solid. Now for the volume, what we do is that we apply what we call Archimedes' principle. Archimedes' principle states that the volume displaced by a solid in a liquid is equal to the volume of the solids. The volume displaced by a solid in a liquid is equal to the volume of the solid. Now what this law is saying is this: if we have this as a bucket of water and we fill it with water, a bucket filled with water, if we put anything inside this bucket that is already filled with water, we see that the water will start overflowing. You say that the amount of water that will come out, that will overflow, is equal to the volume of the solid we put inside this container of water. So for you to get the volume of an irregular solid, what you do is that you put it in a container and check the amount of water that will be displaced, or the amount of water that will overflow or change in the volume of water in the container. That will give you the volume of the solid which you have put inside the container. For instance, if we have this bucket and the level of water is at 2 cm cube, and when you put an object inside it, it comes to a level of 3 cm cube. What it means is that the change in volume is equal to the volume of the objects inside it. That means 3 minus 2, which is equal to 1 cm cube. So this 1 cm cube, which is the change in volume, is equal to the volume of the object which are put inside the container of a liquid. So for us to get the volume of these solids, irregular solids, we put them inside a container of a liquid and see the amount of liquid that will be displaced. We can easily get the volume of the liquid displaced using a measuring cylinder or volumetric flask. It will give us using a measuring cylinder, it is calibrated, so we can get easily the volume of the liquid displaced. And any amount of liquid displaced, we take it as the volume of the solid which we have put inside the container. So that is how to get the volume of an irregular solid. And whatever we get, we now divide the mass of the irregular solid by the volume we now got to get our density for the irregular solids. For example, we may be given this question: an irregular solid of mass 5 kg was placed in a jar of water. If the volume of water displaced is 2 meter cube, calculate the density of the objects. Now solution. Now we know the mass of the objects. Mass of the object M is equal to, mass of the object is 5 kg. So 5 kg, and the volume of water displaced is 2 meter cube. Volume is equal to 2 meter cube. So we take this volume of water that is displaced as the volume of the object which we now inserted inside the bucket or inside the jar. So this is equal to, it is equivalent to the volume of the solids. Volume of the solids. So our density now is equal to mass over volume, which is equal to 5/2, and this gives us 2.5 kg per meter cube. So this is how to get the density of an irregular solid. So in this lesson, we've learned how to get the density of a regular solid and how to get the density of an irregular solid by determining the volume using Archimedes' principle. So that is what we have in this lesson, and I believe that the concepts given are clear. Thank you.